Welcome to your last day of math in this class. I'm sorry. But this is the last day we're going to be doing math together. Have we started the video? And welcome North Central. You might be doing math for another day. I stagger my classes a little bit. So the class after this actually taught this morning. Anyway, so it's our last time doing math because starting Thursday we're going to be watching a movie on calculus. So I realized just before this is actually like my last calculus class that I'm really teaching. Yeah, I know, it's sad, so we got to make it good. Yeah. Okay, you can do good. So we're going to do some matrix stuff. But also, I would like to say I'm really excited for tomorrow to see you guys out there on the stage and announce where you're going to go off to school. I am excited. I'm ready to cheer for you. Okay. Now back to the math stuff. So if you guys can open up your packets that we've been using in class, Daniel and Gerardo, to the one where it starts with matrix operations. Alright, so and I noticed I saw Jessica up here doing a backwards the Matrix movie. Who's seen the movie The Matrix? Yep. Awesome movie. If you haven't, really should see it. It's amazing.
Can we just watch?
Well, so the Matrix in math doesn't really have anything to do with that movie. And so people that worked with me yesterday, sorry guys, this might be a little boring, might be a little repetitive. You can keep working on from there, but I'm going to start just straight from the beginning. For those who are going to be engineers, where are my future engineers? Future computer programmers. You guys will see so many matrices. Like in every math class after calculus 1 and 2, you just see tons and tons of matrices. It also comes up in other sciences as well, but like in terms of math and programming, it is like one of the most useful tools. So what I want you to do is, rather than just reading off all the basic stuff with matrices, I'm on the wrong page, sorry. Rather than reading off all the basic stuff with matrices, you guys can read that for yourself. Just take a minute to scan through this first page, read about what a matrix is. Started in your packet. Where is it? Huh? Okay. Well, this is just introducing what all of these are. Like, and I don't think you guys didn't learn this in algebra 2. I learned it in physics, but I yeah, the year but below you did learn it in algebra 2. They changed the curriculum a little bit. I can't remember. I mean, we're going to do this. 1, 3, 5, 3, 1, 5. 1 times 3, 3 times 1 plus 5 times 5 is 30. No, those are my correct actually. No. Daniel.
Like I just lay on here and
We're just gonna have to keep doing this.
pretend I'm staying away. It works today. Sunday.
Alright, let's talk about it. So, what is a matrix?
A movie.
Yes, it's a movie. What is a matrix in math? Yes, Jessica. That's pretty much it. Yeah, it's just numbers in a rectangle. It's numbers, you might have it in this shape and that shape. That's all it is, but it's surprisingly useful. It has rows and columns, so we call this 1 by 4 because it's one row, 4 columns. So these matrices here, 2 by 2 and 2 by 2. Matrix addition, super easy. You just add each individual piece. So I take 1 plus 5, 6, 2 plus 6, 8, 3 plus 7, 10, 4 plus 8, 12. Like that's all you do. Same thing with matrix subtract, but whatever the next one is. Take 1 second to do the next matrix subtraction. I'm just adding 1 and 5, 2 and 6, 3 and 7, 4 and 8.
Oh, yeah.
This should feel pretty easy. Yeah. Who am I gonna pick on? Guzman, what do we get? Right, we should just get all negative 4s. All negative 4s. Alright, where life gets a little more tricky is matrix multiplication. Oh, sorry, we have to do scalar multiplication. We're still in some easy math here. Matrix multiplication. A scalar. Did someone who was working with me yesterday remind us what a scalar is? We're an AP Physics student. Scalar.
I think that's like the one that doesn't take, the measurement that doesn't take the direction is separate.
Yeah, so I guess that's in AP Physics. That's because it's only just one number. A scalar just means a number. Right? So we just have a number by itself, not a matrix, just a bunch of numbers. When I multiply the number here, just multiply each piece.
Times the scalar.
Right? Times the scalar. So first one I get 5, 10, 15, and the next row. Yeah, like that. That's pretty easy.
Oh, so now over here you multiply.
Right, so now when we're doing matrix multiplication, it takes a little more work. Matrix multiplication, I would have this matrix times that matrix. No, I mean, what are the dimensions of this matrix? Yeah, 2 by 3, we say rows first. The second matrix, 3 by 2. When we're multiplying matrices, right here we have a 2 by 3 times a 3 by 2. The inside numbers need to match. These two need to match, and then we're going to end up with what the outside numbers are. We're going to end up with a 2 by 2 in this case. So if I'm doing A times B, does anyone remember how to do this? Maybe someone from yesterday. Crystal.
It's going to be row times the column.
Yeah, row times column. So can you show us how you get the first number in the top left?
Multiply 1 times 3 plus 3 times 1
Times 3.
plus 5 times 2. And then
5 times what?
5 times, no, I mean 5 times 5.
Yeah.
And then, yeah, you add them together.
Then you should get 31. Where you're taking the first row, multiplying each number by each number in the first column of the second. I take the 1 times the 3 plus the 3 times the 1 plus the 5 times the 5 and add those up. Alright, so the next number, the 1 times the 6 plus 3 times 4 plus 5 times the 2, whatever that is, 1 times 6 is 6 plus 3 times 4 is 12, so it's 18 plus 5 times 2 should get 28. Alright, take a second to get the next two.
Okay, so if you look like this times this, it's gonna be 1 times 3, 3 times 1. You add whatever you get. And then you get 1.
So I take this row and this column.
Yes. And then do the same thing on the second one. 1 times 6 plus 3 times 1.
Oh, I see what you're saying. Yeah, in that sense, I guess you're turning it sideways. Yeah.
No, like 2, I can understand about
Daniel.
Yes. And then go on to the next one.
2 times 3 is 0.
And once you get that, just move on.
So, and then
That's it.
¿Y what is it? What is it?
Just simply copy. So this is versus row, it will be 1 times 3, 3 times 4, 5 times 5. And whatever you get,
That's
you
40.
add the 1 times 3 plus 3 times 1
So if you
plus
what?
5 times 5.
You add it, put it here.
Yes. Then do the second one, which is around 1 times 6 plus 3 times 4 plus 5 times 2.
Did you get 40 for this one?
You should get that here.
Yes. And then do the second with this row. 2 times 3 plus
No. 2 times 3 plus 4 times.
and then you add
Did you get 38?
no. 2 plus 6, so 16.
12 plus, oh.
You forgot, yeah.
Alright, so when you guys do this, you should get 40 and 40.
Yeah.
Alright, the next one you're doing B times A. Now, B times A, you're going to end up with a 3 by 2. So that's B times a 2 by 3. So what should the dimensions of your final matrix be?
3 by 3.
3 by 3, right? The dimensions are from the outside numbers. So it's going to be different than the one above. Alright, find B times A.
How do you get that? 3 times 3.
So it would be you already got the dimension. You can, whatever you get from the outside is what you're going to get from the
So
inside.
outside.
Yeah. That's how big your box is going to be.
So 3 times 3.
That's a 15. This, for this one, B times A is going to go backwards. You're going to start with this.
Wait, it's gonna go. Wait,
You're going to start with the row.
Oh, you're watching that?
wait, it's gonna go. It's gonna go.
Row times column.
Oh, wait, row times.
I know.
Like, mira, Cristo, pon atención. Así, times this. Así.
Yes.
Así.
No. What? Yeah, but you have to stay on this row because you have to do everything in this column.
Oh, okay, so esto acá, luego esto acá, esto.
And that's your first row. That'll be your first row. No, it's not true. in the morning. Oh, she doesn't even sing it a lot. It's just that's the mom.
She keeps saying she's pretty.
So that's what it
Come on. She's like pretty
Alright, that's your matrix you should get.
45, 33.
But Captain Marvel, she's pretty.
No, it's the one at the baby.
But I mean, she could choke it.
She was committed.
Alright, make sure you get these numbers 15, 33, 51, 9, 19, 29, 9, 23, 37. Who got those? What questions are there? Is there still confusion on the whole? Like if you mess up one or two numbers, it's just a number mistake. But if you mess up all of them, then you're misunderstanding something. So what questions are there? No questions? Yes? The order that you do it. So, okay, that would be better if I actually did this. So, you start with whatever matrix is first. I'm going to look at the rows of that matrix. The one that's second, I'm going to look at the columns. So this one, B is first. So to get this number here, I look at first row of B, first column of A. First row of B is 3 and 6. First column of A is 1 and 2. So I do 3 times 1, 6 times 2. What about this one right here? How do I get that number?
Second row.
So you start with rows of the first one. Second row of B. Third column of A. So that comes from 1, 4, and 5, 6. 1 times 5 is 5. Plus 4 times 6. 24, add those up, you get 29. Alright, take 1 second and try the next one.
But we need a light.
There should be a problem with finding A squared. Yes. Well, hold on. A squared, another way to find that, if you want to find a matrix squared, you can do it. Multiply it by itself. A squared just means A times A.
What is the issue?
A squared would just mean A times A. What's the issue? Let's talk about this. What's the issue with doing A times A? Danny.
The number of rows not equal to the number of columns.
Right, if you did A times A, that's what A squared is. That would be a 2 by 3 times a 2 by 3. It doesn't match. Like these numbers don't match. The columns of the first and rows of the second don't match. Like what would happen if you tried to do this? You try to do the first row, the first one, 1, 3, 5, times the first column. You'd end up with 1, 3, 5 times 1, 2. You can't really do that because there's 3 numbers in the first row and 2 in the column. Alright, so what we're going to do is you're going to turn to the next page and work through these practice problems. I'm trying to cover up all the answers here. I'll play some music. Should get this done in about the next 15 minutes or so. Actually, I'll stop you at some point to go over how to do this in the calculator. Yes. Daniel.
These are roses, these are colors. These are roses.
I remind people we did this yesterday. Those are both the second one. Crystal, how's it going? What?
In the summer, it was supposed to be
What? But it's not an any color.
No, yeah, this year told me like
So you did like preparation for calculus?
like matrices. It was like a it wasn't even
But this is like not, it's not in BC calculus. I never learned this.
that was supposed to be
Really?
Yeah, it was
You could use your calculator? That part, because there is a way to do this with calculator that I'm going to show. You got it. Just do the work. You'll recover after this one, right?
If you were just waking up to this, I was telling you what we do.
Yeah, you're right. How much do they want?
No, mixed. So it's these match the 3 days. So that's what.
Oh, 20.
So it's gonna end up being 40.
Up to 25 is a charge.
When you read my rows,
Number 2. Yeah, you're not doing multiplication.
Saying
Right? If you're multiplying those two, that would be easy. But when you're doing subtraction, you want to subtract the dimension you have to be.
just words home, No, no, we don't because if you see that your car makes it, you
You can have half of Well, you actually would be like, look, you're subtracting here and that's I mean, what would you have to do So the rows first, column second, so it's 4 by 3.
My square isn't so
It takes me 2 hours like my hair, so like
That is the thing.
it is like I would just do whatever like I can do with my cousin's graduation. I kind of like people made it to a brand Let me have a weekend on that.
I'll drink hot and happy. 100 years. Started my sophomore year. Well, actually, no, when I first started, I think you guys read, right? That's what started me, and then I read another book. You guys read that for the art? It's hard for like
Are you gonna be measured?
Yeah, it might be harder.
That's all. I
So
was
my
trying to ask
sister's
them, you know, where
my sister's harder to do.
extra nice. There you go. Okay. Because I don't have.
That was it.
I only have contacts. I have a dress, but one dress, I don't want it.
We still have
And then the other dress is like,
Thanksgiving is
but I have two more dresses left. One dress is kind of big.
it's just like
The other one is another dress I have is like,
they're my grandma's.
but I think I'm going to like, but it's like, that's not like, I want to do that.
Yeah, you can.
I mean, I could. It's okay.
Can you see me?
Yeah, he's looking.
So I don't know if this. All right, here are the solutions. Carlos, you okay there? The first one, you just multiply everything by -2. The second one, you were thrown off by the half in there, but it's still doable. Or you just multiply the half into each one of these. And then you add up each piece. I add up like 1/2 times 1 plus 6 times -4 minus 2 times -3. And you get these numbers. Why is number 2 possible?
Not the same number of them.
Jessica.
Because the number is on the outside match.
That's actually not the issue. Well, hold on. What do you mean the number on the outside doesn't match? This and this? Right, so you need to be careful here. We actually would be allowed to multiply these. If this were multiplication, that would be allowed because the inside numbers match, but it's not multiplication. It's subtraction. And we need the dimensions to be exact. So what you're going to say? Sorry for stealing your thunder. So it's not possible. This one actually is possible. 4 by 3 times 3 by 2. Why do I know I can multiply these? Ishmael. The 3 and 3 match. You should get -7, -11, 10, 13, 17, 16, and 0, -81. Is that what it is? -81? Yeah. Alright. But let's say we want to really make sure we know how to multiply these. Your calculator knows how to do it. Computers know how to do it. And like the more you get into math, there's some, especially programming, you're going to run into problems with matrices that are like 1,000 by 1,000. You're not going to do that by hand. You just get a calculator to do it. So can you guys all take your calculators out? And let's learn how to do this on the calculator. Okay, I'm hoping this is just the basics with matrices, but I'm hoping if you see these in a class in college, you'll be more comfortable with them to start out. Are you okay? Like a sickness. No, Daniel, that's not a calculator. I hate them. I hate them. Yeah. All right, what you need to do is, there are 2 ways to do it. One way to do it is you could go menu, not calculus, matrix and vector. Create matrix. And enter the number of rows and columns. You can just click OK. So I'm going to have you delete it. All right, then just delete it. The backspace. Now, the other way you can do it, those are like shortcuts. Go to the button next to the Bible. And I already have it selected. Go to the 3x3 matrix, because that one is going to let you choose the dimensions. Alright, so let's say we're doing this last one. No, too fast. Ishmael, I want you to do a 4x3 and a 3x2. You have 4 rows, 3 columns. So now you can type in that matrix we're looking at. I don't know if you have the notes right there. 1, 1, -1, or whatever it is. -1. So you can type that in, and then you can just do times, type in the other matrix. We're good.
Really?
Is that what you were asking? Which one was columns and which one was rows? You were doing subtraction.
Times, and then just type in the next matrix. Wait, so it's not -81, it's -61. Whoops. I blame whoever told me it was -81. You know, it's bad when you can't read your own things. Yeah, because it would be -5 times 5, which is -25, plus 6 times -2. Alright, so the answer matches up. Alright, so this is just a useful way to check your work. Alright guys, we have about 13 more minutes of math in high school. This is pretty much only 13 more minutes of math that you guys are going to do. Except for those who are going to be, held back, then you'll be doing a lot more math. Or, those who are going to, stay for another year.
Because I won't see this link anymore.
You have these videos to watch next year.
Is that the same?
Thanks for being dramatic. Alright, so let's make these 12 minutes of math good. Get some practice with the problems below. Check your work on a calculator. And if you don't have a calculator, you can't check your work, so you better be good. Imaginary class dividing into classes. You can somehow write the matrices to represent that. I'm on video too.
That's a bit cool. Bueno, en el no estás con I don't know. Perfect.
First page. Can you put these
White and gold.
Alright guys, here are the solutions to the next 4 problems here. 18, 4, 32, negative 6, 18, 42. 7 is impossible. Why?
They're both 2 by 3.
Why?
It's 38.
That's why it's impossible. What are the dimensions of B? 3 by 2. What are the dimensions of A?
3, 2.
No, they're both 3 by 2.
Oh.
3 by 2 by 3 by 2, you're not going to be able to multiply those. And then you can check these two. Alright, guys, let's do 2 more math problems in high school. Just 2 more. So make them good. It's your last 2. We're going to start watching a movie on this. It depends on whether we get these problems right or not. If we don't get them right, then maybe we need more practice. It's a short day. Leave early for Wait, Friday's the Friday. I'll set it Friday. Are you gonna dance at prom? No, déjalo que Alright guys, for those who got through these, you end up with the same matrix as the beginning when you multiply this out. 8 fed negative 2, negative 1, 0, 1. And that's because this is a very special matrix called the identity matrix. And then these you end up with just ones on the diagonal. Zeros you end up with the and this would be our next lesson, but we're not going to do this part. Alright, seriously, good stuff guys. Congrats on finishing high school math. Now we're going to be watching a movie on Thursday. And North Central students, I'll see you at prom. Station 6:30 to 8:30, somewhere in the bell tower, I don't know where.
And I'll be
Supervising.
home. Oh no, I
Pretty good.